Hello everyone, welcome to Math Direct. So today's video I'm going to be talking about derivative of trigonometry. So if you talk about trigonometry, you talk about the sine theta, cosine theta, tan theta, and all that. So this video I'm going to show you guys on how you can solve a derivative of sine, cosine, theta, and tan theta, and any trigonometry regardless. Like we have the inverse of any sine theta, inverse of cos theta, or tan theta, inverse of tan theta. But you need to understand the laws. There's the laws behind this. And let's say, back in high school, a lot of people have learned about SOHCAHTOA. SOHCAHTOA, this is sine theta. This is cos theta, and this is tan theta. So this is the baseline. This is the base. This is what a lot of people know, and you can differentiate tan theta, cos theta, and tan theta. So if they ask you to differentiate sine theta, it's cos theta. Differentiate cos theta is minus sine theta, and differentiate tan theta is sec squared theta. So you need to understand the laws that applies to this in order to solve derivatives. So let's say we have d over d theta sine theta is equals to cos theta. D over d theta cos theta is equals to minus sine theta. Okay, if you have a problem, d over dx, so 4 sine 3 theta. So your u here, u will be equals to 3 theta, and you differentiate this, so the u over d theta is equals to 3. So you replace u over here. So this will be y. Let's say y equals to 4 sine u. And now you have to differentiate. You have to differentiate this. So we differentiate 4. Differentiating a number is 0. So 0, and keep sine constant, sine u, plus differentiate sine is cos u, and keep 4 constant. So this is 0. So this is cos. So this is 4 cos u. So this is dy over du. So dy over du is this, but it's not done yet. So we have to apply the chain rule here. So dy, so we try to find dy over d theta. So it's equals to dy over du times du over d theta. So du cancel. We have dy over d theta. So we already have du over d theta over here, and we have dy over du over here. So we have it done now. So we have to times it together. So this problem is 4 cos u times 3, and 4 cos u over here is 3 theta. 3 theta times 3. And 4 times 3 is 12. So dy over d theta is equals to 12 cos 3 theta. So this is your answer. So differentiating 4 sine 3 theta gives you 12 cos 3 theta. So this is your answer. So 4 cos 3 theta. How do you differentiate this? We use product rule as well. So u here, we call u as 3 theta. So u is equal to 3 theta. We du over d theta gives you 3. And our goal here is to find dy, so we call this y, dy over d theta is equals to du over d theta times du over d theta times dy over du. So we have 3 here. We need to find dy over du. So this is 4 cos u. So we apply product rule as well. So 4 differentiate 4 is 0 plus differentiate cos u is minus sine u, and keep 4 constants. So this is minus 4 sine u. So this is dy over du. So dy over d theta is equal to 4 minus 4 sine u times 3. So which is 12 minus 12 sine u, which is minus 12 sine u is 3 theta, so sine 3 theta. So this is the answer when differentiating this. So if you understand how to use the rule in trigonometry, memorize when differentiating sine is cosine theta, when differentiating cosine is minus sine, when differentiating tan is sec squared theta. If you understand these rules that applies to trigonometry, you can actually solve questions like this. So looking at this equation, you know that we will apply quotient rule in order to solve this kind of problem, because there's division there and we can assign quotient rule to solve this kind of problem. So understanding quotient rule will help you figure out what this problem is all about and how you can tackle this problem. So let me explain what quotient rule is all about. So when you're given something like this, let's say we have fx over gx. So this, if you look at this equation here, this looks similar to inverse of sine theta. So we apply quotient rule here to solve this kind of problem. So how can we apply quotient rule here? We need to differentiate the numerator and keep the denominator constant, minus differentiate denominator and keep the numerator constant, divided by the denominator square. So differentiate fx is df over dx, and you keep g constant. Differentiate minus differentiate the denominator dg over dx and keep f constant, divided by g squared. So we are going to use this rule in order to solve this 1 over sine theta problem. So 1 over sine theta, you differentiate the numerator. Numerator here is 1. Differentiating a number is 0. So 0, keep the denominator constant, sine theta, minus differentiate sine theta will give you what? Cos theta. So minus will give it minus cos theta, and keep 1 constant. 1 is 1, and divided by sine theta squared. So 0 times any number is 0 here. Now we're left with minus cos theta. So minus cos theta divided by sine square theta. So this is dy over d theta. So looking at this equation, we can actually break it down further in order to simplify our answer. Okay, so we have the denominator here, we have sine squared theta, and the numerator we have cos theta. Looking at this equation, you understand, if you go back to your trigonometry, we understand that tan theta is equals to sine theta over cos theta. So looking at this equation here, we can break it down. So we can say cos theta divided by sine theta times 1 over sine theta. So this equation here is the same as this equation. One minus sign here is the same, similar. And if you look at this equation here, cos theta divided by sine theta, tan theta is equals to sine theta divided by cos theta. So this is inverse of tan theta. So this is inverse, we have to inverse it. So this is 1 over tan theta times, so 1 over sine theta is equals to cosec. Is equals to cosec theta. So this is the same as that. An inverse of sine, you can break this down a little bit further. Inverse of tan is equals to cot. It's equals to cot theta. So 1 over tan theta is cot theta times cosec theta. So this is your answer now. So you've broken this answer into a simpler, minus here please. You've broken this answer into a simpler form. So this is dy over d theta. So this is your answer. So understanding trigonometry, understanding the rules that applies to it helps in order to solve, in order to tackle any problem. When you see any problem, let's do another example. So let's say we have 1 over cos theta. Okay, cos theta. You know, as I explained before, we apply quotient rule with this, and we do it the same way in the previous example on how to solve this kind of problem. So we differentiate the numerator is 0, keep cos theta constant, minus differentiate cos theta. Cos theta is equals to minus sine theta. So minus sine theta, and keep one constant, divided by cos theta squared. So 0 times anything is 0. So now we have minus sine theta divided by cos theta squared. So minus is plus. So this is sine theta divided by cos square theta. And we can break this down further. So sine theta divided by cos theta times 1 over cos theta. So sine theta over cos theta is equals to tan, you can say tan theta times 1 over cos theta is what? Sec theta. So this is your answer. This is how to solve this kind of problem. So your dy over d theta is equals to this. So I'll stop here. I've applied quotient rule in order to solve trigonometry questions. I have applied product rule in order to solve trigonometry questions. I think if you apply all these rules, I think you'll do well. You will solve any trigonometry questions. My next video, I'm going to be solving a lot of problems and showing you guys on how to implement all these rules on problems like this. It's easy, you know. So thank you so much for watching, and make sure to subscribe to Math Direct. So make sure to subscribe, and I will see you guys later. Peace.